June 9th, you guys are getting a review of Chapter 2. Amazing. June 9th, 2011. This is the second half of the Chapter 2 test. So, you guys are getting the second half of the test. The first half is already up and recorded. So, questions 1 to 5 are already done. You guys are watching 6 to whatever the end of this test is. Okay? So this is Chapter 2-3, technically, this test. And the first question says, quadrilateral MNOP has vertices 2, 4, negative 2, 2, negative 1, 0, and 3, 2. Verify that quadrilateral MNOP is a parallelogram. So, there's several ways you could do this. A, you could find the distances of all of the opposite sides. You know, let's actually draw this first, just so that you understand what I'm talking about. Oh, there we go. Let's graph this. So, anyone have the test with them? So I don't have to keep scrolling back. Okay, so if you're looking at the test right now, point M is at 2, 4. So I go 2 across the x-axis, 4 up the y. Here's 1 point. Point N is negative 2 and 2. So go negative 2 up 2. That's point N. Point O is negative 1 and 0. That's right here. And point P is 3 and 2. So this is a quadrilateral, so they say. And we need to prove that this is true. So obviously it has 4 sides. Now there's several ways we can do this. A, we can find the distances of opposite sides, make sure they're the same distance, and then discover that they're parallel, all the opposite sides. And if that holds true, then yes, this is a quadrilateral. Or, with a quadrilateral, there's one rule. If the bisectors cross at their medians, so they have the same midpoint, then it is a quadrilateral. That is a much faster way to solve this. Okay? So instead of finding all these distances and if they're parallel, we're just going to find the 2 diagonals and their midpoints. Once we find their midpoints, if they're the same, then we have a quadrilateral. Okay, so we're going to get started on the actual math of this question. Okay, so we need to find that the midpoints between our 2 lines are at the exact same point. So first of all, I did forget to write in 1 letter. That's a P, right? Okay. So first of all, one of our diagonals is O and N. So we'll do that in red. N and O are diagonal from each other. As you guys can see, these 2 are diagonal. So I need to find the midpoints between these 2 lines. Does anyone remember the midpoint formula? X1 plus X2 divided by 2, comma, that gives us the first coordinate, y1 plus y2 divided by 2. That gives us the y coordinate. So that's going to give us the midpoint between M and N, and we're going to have to do the exact same thing for N and P. Oh, sorry, we're supposed to be doing O and M. Someone corrected me on that. O and M. Okay. All right, so let's start doing this. We'll do this one in red. X1, which we'll call M R1 and O R2. X1 is 2, and x2 is -1 divided by 2. y1 is 4, and y2 is 0 divided by 2. 2 subtract 1 is 1 over 2. And 4 plus 0 is 4. 4 divided by 2 is 2. So our midpoint is a half. So x is a half, and y is 2. You could have also written that as 0.5 and 2 if you like, okay? The other midpoint we're going to find is from point N to point P. Exact same formula, but I'll do this one in blue. x1 plus x2 divided by 2. y1 plus y2 divided by 2. Okay? We're using N and P this time. Those are our two opposites. So our x1 is our N, and we'll call P our 2. x1 is -2 plus 3 divided by 2. And y1 is 2, and y2 is 2 divided by 2. -2 plus 3, 1 over 2. 2 plus 2 is 4 over 2. And when we equate these, we get 1/2 or 0.5 and 2. So are our two midpoints the same? Yes. So because the midpoints of diagonals are the same, that proves this is a quadrilateral. This would have been the fastest way to solve this. Remember, you could have found parallel sides, proven they're all parallel, so same slopes, and the distances being the same, but that would have required 8 equations, when this one only required 2 equations. Okay? So try to remember that rule in terms for your exam. Okay. B says to verify that the diagonals of MNOP are of equal length. So that means we have to show the distances. Does anyone remember the distance formula? There we go. You guys got it. You're so smart. Okay, distance formula. D is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. Sorry, I forgot to write that. Okay? So, again, they want us to verify diagonals. So, again, we're going to use those same two diagonals. We're going to match up M and O and N and P. Oh, I'm impressed I could say that. Okay. So, we're going to use the same distance formula for both. I'll use red again for M and O. So, D is equal to the root of our x2 is -1, and our x1 is 2. So, we have -1 minus 2 squared plus y2 is 0, and y1 is 4. So we have 4 subtract 0 squared. -1 minus 2 is -3 squared plus 4 squared equals 9 plus 16. Equals the root of 25, which equals 5. So the distance between M and O is 5 units long. They didn't give us a measurement for this one. Yeah. Okay, the other diagonal that we have to prove the length of is from point N to point P. So we'll do that one in blue. Exact same formula. We're using our distance formula again. Distance is equal to the root of our x2 is 3, and x1 is -2. So that's going to say 3 subtract -2 squared plus y2 is 2, y1 is 2. So 2 minus 2 squared. 3 subtract 2 is the same as 3 plus 2. So we have 5 squared. And 2 minus 2 is 0. 0 squared. Gives us the root of 25 plus 0, which is equal to root of 25, which is equal to 5. So we've now verified that the diagonals are both 5 units long. Okay, question says, determine the equation of the right bisector of the line segment joining P, 0.26, and Q, which is 0.4, negative 2. Okay, we're going to quickly graph that. Okay, so point P is at 2 and 6. I think that's a 6. It's hard to see. Point P. And point Q is at 4 and negative 2. So go over 4, down 2. So this is our original line. And we need to find the equation of the right bisector. So, first of all, right bisector goes to what point of this line? The midpoint. So we need to find the midpoint. It's going to be somewhere there. And it needs to be what? Perpendicular. The right bisector needs to be perpendicular to this. So however it looks, it needs to be a perpendicular line. So we know that's how the slope is going to be. Okay? So we need to find this, essentially this blue line. Let's start doing the math for it. Okay. So first thing we need to do is midpoint, which we remember the formula from before, x1 plus x2 divided by 2. Whoops, that's not a y. y1 plus y2 divided by 2. Okay? These are our 2 points. We'll call P1, Q2. x1 is 2. x2 is 4, so we have 2 plus 4 divided by 2 is going to be our first midpoint, or x-coordinate of it. And y1 is 6, and y2 is negative 2. So it's 6 plus negative 2 divided by 2. 4 plus 2 is 6 over 2. 6 plus negative 2 is 4 over 2. Our midpoint is 3, 2. Okay? So let's assume that's right on. 3, 2. We have our midpoint. So I have 1 point of the line. What else do I need to find of this? Anyone know? To prove that something's perpendicular, what do I need to have first of PQ? I need the slope of line PQ first. So our slope formula, slope is equal to y2 minus y1 divided by x2 minus x1. Okay, that's rise over run. Our y2 is negative 2. Subtract y1 is 6. Divided by x2 is 4. x1 is 2. Negative 2 minus 6, negative 8. 4 minus 2 is 2. Our slope is negative 4. Now, I found the slope of PQ. That's this slope here. Negative 4 over 1, you could say. That's our slope. In order for something to be perpendicular, it needs to be what of that slope? Negative reciprocal. So in other words, our slope of negative 4, 1, we need to flip it and change the sign. So the perpendicular slope of our right bisector is going to be positive 1 over 4. So the slope of our right bisector is positive 1 over 4. So let's do our equation of a line. Y is equal to mx plus b. We know our m is going to be positive 1 over 4, x plus b. And I need to find the y-intercept, obviously, for the equation. So I already have a point. I have the midpoint of PQ, and we also know that point goes through this right bisector. So I'm going to take my x and my y value and plug them into this equation. So I'm going to substitute number 2 in for y, and I'm going to substitute number 3 in for x, and we're going to solve for b. 2 is equal to 3 over 4 plus b. 2 minus 3 over 4, I bring the 3 over 4 to the other side, is equal to b. I'm just going to go up here to save some space. I need to make 2 into a fraction that has a common denominator. So I need a common denominator of 4, which means I need to multiply this whole fraction by the number 4. So I'll get 8 over 4 minus 3 over 4 equals b. 5 over 4 equals b. And equation of our line, y is equal to 1/4, which was our slope, plus 5 over 4. Okay? That's the equation of our right bisector. So there's quite a bit to do to that question. We had to find the midpoint, slope, negative reciprocal, and the Y-intercept. On here. Okay, question 8. A quadrilateral has vertices blah. Find the midpoint, okay? So I'm going to find those midpoint right now. Let's plot them first. Okay, so if you take a look at this, point R is -4, -1. Point S is 0, -4. Point T is 6 and 0. And point U is 0 and 4. All right. That's what it says. All right, it just says quadrilateral. It actually doesn't say that. Okay, so there's our quadrilateral. We've drawn it on there. Find the midpoint M. So they want you to name this point M. And it's the midpoint between point R and S. I forgot the last point. What was it called? T, right? No. U. Okay. So they want the midpoint of RS, and we're going to call it M. So midpoint formula, x2 plus x1 divided by 2, y2 plus y1 divided by 2. We're talking about point R and point S. We'll call this 1, this one 2. So x2 is 0, x1 is -4, y2 is -4, y1 is -1. We get -4 over 2, -5 over 2. So our midpoint is at -2. And we're going to make this a mixed fraction so you have an idea of what we're talking about. -2.5. Okay? If you left it at -5 over 2, that's fine. But I made it a mixed fraction so you had an idea of where that's supposed to be on the graph. So we have the midpoint. It says find that midpoint N of ST. So we're looking for another midpoint here. And it's between these 2 points, S and T. So do this in one in red. S and T, same formula. We're going to call point 1 S and point T 2. So x2 is 6, x1 is -4, little technical difficulty. Thank you. Is it going? Oh, there it is. Okay.
Why do you have to do this?
Okay, 6 minus 4 is 2. Y2 is 0. And Y1 is negative 4. We're just going to go over here so we have space. 6 minus 4 is 2. 0 minus 4, negative 4 over 2. So midpoint between ST is 1, negative 2. So we have our two midpoints. This could be also written as 2.5. We'll scroll down to question C. It says verify that the line segment MN, which are the two new points we just made. This midpoint was M. We call this midpoint N. Is parallel to one of the diagonals of the quadrilateral. So there's going to be two diagonals. One of them is going to be SU. It's pretty obvious that if I draw this new line segment, MN, that those two won't be parallel. So I'm going to have to try and prove that MN is parallel to RT. So which means I need to find the slopes of both points RT and points MN. So our slope formula. Y2 subtract Y1 divided by X2 subtract X1. And we're talking about points R and T. I'm going to write them in up here so we have a reference point. R is negative 4, 1. Point T is 6, 0. Okay? So let's find the slope of RT first. We'll call R1. We'll call T2. Y2 is 0. Y1 is 1. So 1 or 0 subtract 1. X2 is 6. X1 is negative 4. We'll get negative 1 over 10. So our slope is negative 1 over 10 for points RT. Point M and point N are the other two slopes we need to find. Point M was at negative 2, negative 2.5. And point N was 1, negative 2. We'll call it MR1 and our 2. Y2 is negative 2. Subtract Y1, 2.5. And X2 is 1. And X1 is negative 2. So we end up negative 2 minus 2.5 will give us negative 4.5 divided by 1 plus 2, which is 3. Oh, we made a little error here, guys. This midpoint is supposed to be ST. I plugged in the wrong numbers, it looks like. I had 6 minus 4 here. It should actually say 6 minus S. 0. Our x-coordinate is 0 there, not 4. That's where we made our little error. So we'll quickly go back and fix this. This becomes 0, which makes this 6, which makes this 3. Okay? Yeah, I can just erase it. So 3, negative 2, which then carries down over here. This point should be 3, negative 2. So when we go to put our slope in, our x2 should be 3. It still doesn't work. We're getting there. Let's go back and check our mistakes. Because it's telling us to prove something, so we're getting there. We just got, this was 5. What else did we miss? The only other error we made is a copying error. This is negative 2.5. So this says subtract negative 2.5. So in other words, negative 2 subtract negative 2.5 is like negative 2 plus 2.5. So it gives us 0.5. Now, these are equivalent. Oh, yes. Negative. No. No, it shouldn't say negative. All right. Another small error. Again, guys, make sure you copy questions down properly because I clearly didn't. That should say negative 1, which makes this subtract negative 1, which makes this positive 1 over 10. That's why this is also positive. It was not a negative. Those are equivalent fractions, 1/10 and 0.5 over 5. If I multiply this by 2, I get 1 over 10. So it's finally, after all of our little mistakes, proven that these two are parallel.